Hi, this is Marie Antoinette Giswicon, a BSE3 student, major in mathematics. Today, I will go on to create a tutorial on how to compute a paired t-test using the Excel. But first, let us know what is a paired t-test. This paired t-test, also called as paired sample t-test or dependent sample t-test, tells you how significant the difference between groups are. In other words, it lets you know those differences could have happened by chance. And always remember that you can only choose to use the paired t-test when your sample matches the following. First, you have a measurement with the same item, person, or thing. Second, if you have two items that are being measured with a unique condition. Third, if the distribution of the differences between pairs of score is approximately normally distributed. So if your data matches the conditions, then you can use the paired t-test. I prepared here an example. A study was conducted to determine the effectiveness of a weight loss program. The table shows the before and after weights of 10 subjects in the program. Is the program effective in reducing weight? So in here, we will test if there is no significant difference between the weights of the 10 subjects before and after the program. To compute the t-value using the paired t-test, all you need to do is to list the values of before and after weights. Here I already listed the before weights and the after weights. The first thing that you need to do is to go to the data. Here is the data, then click, then this thing will appear. All you need to do is to find the data analysis. By the way, if you still don't have a data analysis, just install it in your Microsoft Excel. After you find the data analysis, just click and this thing will appear. After that, just scroll, then find the t-test paired to sample for means, since we are computing for paired t-test. Then mark and click OK. After you click, this will appear and you just need to input what is asked. First is the variable 1 range. Here is the box, just click, then go to B, then mark the column of before weight. Then second is the variable 2 range. Click the box, then mark the after weights. Next is the hypothesized mean difference. Since we are testing the null hypothesis, we are going to input 0. Then check the label. Next is you can change the alpha if you are testing a different alpha, but in our example, we will use the 0.05. In the last part, you can just click anywhere in the Excel where you want to put the result. Then, click OK. That's it. All the computed value will already appear. Let's just do some adjustment. In here, the result already shows the mean for before and after weight. For the before weight, we have 206.5. For the after weight, we have 193.1. The variance is 784.72 and 361.66. Observation is 10. Pearson correlation is 0.93. Hypothesized mean is 0. Degree of freedom is 9. Then the t statistical value is 3.37. Then the T-critical two-tail is already given, which is 2.2623. To determine if we will reject the null hypothesis and accept the alternative hypothesis, we need to compare the T-table value or critical value to our calculated T-value. If our calculated T-value is greater than the value of an alpha level of 0.05, then we can reject the null hypothesis. Since our calculated T-value, which is 3.37, is greater than the T-critical value, which is 2.2623, then we need to reject the null hypothesis that there is no significant difference between the weights of the 10 subjects before and after the program. Therefore, we can say that the program is effective in reducing weight. That's how we calculate the paired t-test using the Excel. We can see that it is easier and saves more time. That's all. I hope you learned something today.